X is a random variable with uniform probability density function in the interval -2 to 10. For y is equals to 2x minus 6, the conditional probability y is less than equal to 7 given x is greater than equal to 5 rounded off to 3 decimal places is. The NPTEL video reference for this question is Lecture 21 Probability Foundations for Electrical Engineers by Dr. Krishna Jagannathan from Department of Electrical Engineering, IIT Madras. Some useful information in order to solve this question. The uniform PDF is the one which takes a constant value of probability density function between two finite real values of random variable. The mathematical representation that random variable x takes a uniform PDF between a to b is this. The constant value is given by 1 over b minus a, where a and b are the respective values of the random variable x between which it takes a constant value. The conditional probability that random variable y lies between two values y2 and y1 given that random variable x lies between two values x2 and x1 is the probability that y lies between y1 and y2 intersection probability x lies between x1 and x2 divided by probability that random variable x takes a value between x1 and x2. Given x is a uniformly distributed random variable between -2 to 10, a uniformly distributed random variable takes a constant PDF between 2 points and the PDF is given as 1 over the difference between the 2 points. In this case, these points are 10 and -2 respectively. In the question, we are asked to calculate the probability that the random variable y takes a value less than equal to 7 given the condition that the random variable x takes a value greater than equal to 5. This conditional entropy can be written equivalently as it is given that y is 2x minus 6. From here we can write x as the condition imposed on x is that it should be greater than equal to 5. Applying this condition, we get, or equivalently, y is greater than equal to 4. So this probability can be rewritten as probability that random variable y lies between 4 and 7 divided by probability that random variable x is greater than equal to 5. Probability that the random variable y lies between two limits y1 and y2 can be simply obtained by calculating the integral of its PDF between those two limits. So the given question can be rewritten as in order to find the solution to this question, we need to determine the PDF of y. Cumulative distribution function CDF of random variable y is the probability that it takes a value less than a real number small y. We can write y is equals to 2x minus 6 in this expression, which becomes the probability that random variable x takes on a value less than equal to y plus 6 by 2, which is equal to the CDF of x evaluated at y plus 6 by 2. So the CDF of y can be written as, differentiating this equation with respect to y on both sides, we get derivative of CDF is its probability distribution function PDF. So the above expression can be written as substituting the PDF of y in the required expression, we get now we need to make a substitution in the numerator of this expression. We can write y as 2x minus 6. Then dy can be written as 2 times dx. Then the lower limit of this integral becomes 4 plus 6 by 2 is equals to 5, and the upper limit of this integral becomes 7 plus 6 by 2, which is 13 by 2 or 6.5. After making this substitution, we get the integral in the numerator is the area between 5 to 6.5 of this PDF. Since this region is a rectangle, the area can be calculated as height times its width, which is similarly the integral in denominator is area of the shaded region between 5 to 10, and this can be written as, so this evaluates to 1.5 by 5, which is 0.3. So the required probability that random variable y is less than equal to 7 given the condition that random variable x is greater than equal to 5 is 0.3. So the final answer to this question rounded off to 3 decimal places is 0.3.